Okay, let's conduct a quick sound check. If you are listening in as a participant and you can hear me okay, if you could type a quick note into the chat, that would be very helpful. Thank you. All right. All right, thank you so much. Well, good morning, afternoon, or evening, everyone. Welcome to the NASA CSDA Program Vendor Focused Capella Space webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Time, so we are going to go ahead and get started here. What I'll do first is begin today's webinar with a few logistics. To ensure the best audio experience, excuse me, all participants have been placed in silent mode, but if you have any issues or you have any questions, please enter them into the Q&A panel rather than the chat, and you can find that on the right side of your screen. If you do not see that, there are 3 dots at the bottom of your screen, and if you click on those, that should be the bottom right corner. That should pull up your panel options, and you can insert a check mark next to the Q&A panel. And Geraldine, if you could please place the audio tips into the chat for me, that would be very great. I appreciate that. All right, so today's webinar is being recorded. The recording will be posted to the Commercial Satellite Data Acquisition Program playlist within our NASA Earth Data YouTube channel within, usually takes me about a week of completion, but I will, it could be just 3 or 4 days or so. Once completed, I will send an email to all registrants and participants that includes links to both the recording as well as to the presentation slide decks that are used within today's webinar. As far as timing is concerned, today's webinar will be 1 hour long with 45 to 50 minutes allocated to the presentation and live demonstrations. A 15-minute Q&A period will follow, and depending on the volume of questions we receive, we may extend the Q&A session an additional 15 minutes from end time, but we will have a hard cutoff of 3:15 p.m. Eastern. During this afternoon's webinar, we will have 1 speaker from NASA's Commercial Satellite Data Acquisition Program and 1 speaker from Capella Space to present the vendor content. Dana Ostrenga will be our first speaker this afternoon. She is the NASA CSDA project manager here at Goddard Space Flight Center. She will kick us off with an introduction to the CSDA mission and program goals, provide an overview of the Commercial Satellite Data Earth Science Research and Applications, or CESRA, ROSA Solicitation, and also provide a brief overview of the NASA CSDA Capella Space contract and data access. From there, we will transition to our Capella Space speaker. Our speaker for today is Dave Jones. Dave is an intelligence production manager and senior imagery analyst at Capella Space. He'll begin today's event with an introduction to Capella Space, its suite of satellites, and core synthetic aperture radar, or SAR, data product suite. He will continue with information about applications and use cases for Capella's product suite. Once Dave has finished with his presentation, what we'll do then is we'll move to an optional final set of polling questions, and then we'll open up the question and answer session. And so before I toss it over to Dana, I'd like to say a few words about this afternoon's Q&A session. Excuse me for 1 second while I advance this slide as well. We'll have 2 technical POCs from Capella Space who will serve as Q&A panelists at the end. The first Q&A panelist is Tom Rapetti, a systems engineer, and Jim Klukar, a senior radar processing engineer. We'll try to answer all of the questions within the time allotted, but if we're not able to address your question during the Q&A period, our speakers will be able to follow up with you, offline. With that, it is my pleasure to introduce today's first speaker, Dana Ostrenga. And so Dana, with that, I will stop sharing my screen and so that you can, and toss it over to you so that you can share yours.
Thanks, Jennifer. You can see my screen?
I sure can. Thank you so much.
Great. So thanks, Jennifer, for getting us started today. Welcome again all to the Commercial Satellite Data Acquisition Program webinar series, where we're here today to learn about Capella Space. So I am Dana Ostrenga, the CSDA project manager at NASA Goddard Space Flight Center. If you missed any of our previous webinars, just to give you a little background, this Commercial Satellite Data Acquisition Program, or CSDA, has the mission to focus on identifying, evaluating, and acquiring commercial satellite data that support NASA's Earth science research and application goals. The program itself has 5 main goals. One is to establish a continuous and repeatable process to on-ramp new commercial data vendors. Also, to enable sustained use of that data for broader dissemination to our scientific community, to ensure long-term data preservation, access, and distribution of that data, ensuring scientific reproducibility, and to collaborate and partner with interagency and international partners on the evaluation and scientific use of the data. And then finally, just to comply with the 2003 US commercial remote sensing policy. If you missed any of our previous webinars, there is a link to the prior recording that talks a little bit more in depth about our program. So we recently completed our IDIQ on Ramp 1 back in September 2024. And this was a multiple award on an indefinite delivery, indefinite quantity, fixed price contract in response to RFP that closed in earlier that year in March of 2024. The contract goes for 5 years through 2028, and we've awarded 8 new vendors under the IDIQ on Ramp 1, which includes BlackSky, ISci, MDA, Pixel, Planet, Satellogic, and Teledyne Brown, and then finally the Tomorrow companies. These 8 new vendors join our previously awarded 7 vendors on IDIQ. This means that if they are new to the CSDA program, we will evaluate their data, and then once complete, they'll be able to propose to competitive task orders. And if they are previous vendors that have held a blanket purchase agreement or BPA contract and have been evaluated, they can now compete under the IDIQ. But with new products, any new products that haven't been evaluated, they will need to be done through our program before being able to be provided as offerings in competed task orders. We have 2 types of contract vehicles, like I just mentioned in the previous slide, currently with our vendors. One is that IDIQ contract, and the other are BPAs, which we're currently closing out the BPAs in favor of administering a more competitive task order process with the IDIQs. We've been building upon our collaborations with federal partners as well as international partners when it comes to data assessments, new capabilities, and data sharing. We're also working to create a more efficient search and discovery of the data within our program for authorized users through our own program portal, but also by integrating with the NASA Earth Data Search client. Our program is still heavily focused on the continued assessment of the quality and utility of the data. So just looking at our vendors listed here and in reverse timeline order, we have kicked off the evaluation recently of the Planet IQ and Umbra Lab data. We begun discussions with the PIs who will be conducting those evaluations, making sure that they get the data they need. We have 4 evaluations that are nearing completion from the BPA on-ramp 3 solicitation. That's GHGSat, GHGSat, GeoOptics, Capella Space, and ISci, which have completed the evaluations and the debriefings. The final reports will be made available soon to the public, and the data acquired for those assessments, with the exception of ISci, is available on the SmallSat Data Explorer, which I'll show in a moment. We have also completed the evaluation process for BlackSky and Airbus US, which were part of our BPA on-ramp 2 solicitation. We do have DESIS and EarthM data that was brought in through our pilot program and as part of a cooperative agreement. And we've brought in Planet Inspire data through BPA task order and a continued IDIQ task orders for data continuity. And we also bring in Maxar data via an NGA agreement. We do want to mention that recently we had a ROSA solicitation that went out, A.48. It's the Commercial Satellite Data Earth Science Research and Applications call. We are soliciting proposals now. The idea behind this data call was that PIs would demonstrate how commercial data supplements existing capabilities of the NASA's Earth observing fleet and offer free and open data sources. We will offer the ability to access the data and provide background documentation on each of the data that is offered through the program that I mentioned previously. This is open to any research and applications that can contribute to the objectives of the Earth to Action strategy. And here are the dates listed. We did extend the mandatory step 1 due date due to the recent fires in California. So the new due date is February 14th. And you'll see a link, you'll get a copy of these slides to the NSPIRES, the call on NSPIRES. So Capella, that we're here to talk about today, has been part of the program since December 2021, when they were previously awarded a blanket purchase agreement to acquire SAR data in the purpose of evaluation. Capella entered an IDIQ contract in October of 2023 as part of our On-Ramp 1 in September of 24, and they updated their catalog offerings. They were awarded a 12-month task order in August to provide the new data offered to the program for continual evaluation. The program did an evaluation of the initial acquired SAR data and provided a full assessment, which will be released soon, along with the data that was acquired through that evaluation process for authorized users. There's an existing USG EULA for the use of the data acquired under the first evaluation. So if you qualify for access under our licensing agreements, you can get authorization through the CSDA web form to acquire that data through the SDX Explorer. You can see the suite of data, the program that is acquired within the Explorer on our website, in which Capella will be added, and you'll hear shortly from Capella on those individual products. You can see here a screenshot and link of our SmallSat Data Explorer, where you can search and access data as an approved user. The data that is downloaded will continue to be integrated and available through this interface, and as I mentioned previously, also being added to the Earth Data Search client alongside NASA's flagship missions. So that brings us to the next portion of our webinar. Please welcome our invited speaker, Dave Jones, who will talk to you more about Capella. I'll stop presenting, and Dave, you can take it away.
All right.
Give me 1 second. I got to figure out how to stop this.
Okay.
There we go. I think you can go ahead.
Yep. Second here. All right. Dana, Jennifer, thank you for the introduction. First, let me say we at Capella Space would like to thank you all for taking the time in your busy schedules to listen to today's webinar. As Jennifer said, my name is Dave Jones from Capella Space, where I'm currently the engagement lead. And for the next 40 minutes or so, I'll be giving you a brief briefing on some basic SAR knowledge and a short capability brief on what Capella Space can provide you. They always say, how do you know when you've been in the career field too long? Well, the equipment you used to work on is sitting in a Smithsonian, as you can see from this photo. So what is SAR, synthetic aperture radar? Well, in 1951, Carl Wiley, an American mathematician and engineer at Goodyear Aircraft Company, invented what we now call synthetic aperture radar. Throughout the 50s and 60s, Wiley and Goodyear had made significant advancements in SAR technology. Using pulses of radio waves that are transmitted from the sensor to the ground to illuminate a target, the echo is received, measured, and recorded, and provides you that image you see. Typically, the larger the antenna, the higher the image resolution will be. But by using a synthetic or moving antenna, this allows SAR to create higher resolution images with a smaller physical antenna. Without this concept, the antenna would be at such a large size that it would likely be cost prohibitive to use. All right, so we'll go back to, let's see, I already talked about antenna. So one of the key features about commercial SAR is the very high resolution that is capable. If you're familiar with the NIRS scale, the National Image Interpretability Rating Scale, most vendors are hovering around that 5 to 6 NIRS factor. Another aspect that you mostly hear is the ability for SAR to work in any weather condition, day or night. Since the 1950s, as with all technology, we've been able to make satellites smaller and more powerful, allowing for broader commercialization. Germany and Italy were one of the first to commercialize SAR imaging, and in 2018, Capella was the first US-based ComSAR provider. So we talked a brief history on SAR and how it works, but what can we be used it for? If you look on the right there, some of the current applications for SAR: Earth observation and environmental monitoring, natural disasters pre and post, agriculture, mapping, change detection, and the P here is releasability to partner nations. Let's talk the advancement of imaging satellites over the years. The airplane you see on the left is capturing a canister from the Corona series of satellites. These canisters were ejected from space that was then captured mid-air over the ocean by an aircraft. If you take a moment, just reflect on how complicated of a process this was to achieve. This was common practice for the US in the early 60s to early 70s. While advanced at the time, the latency to receive the imagery after collect could be several days to weeks before the imagery was able to be exploited. Now we'll fast forward a few decades. In the middle photo, we have SAR Lupe, Germany's first recon satellite. This, along with others, such as Cosmos SkyMed, were really the first commercially based SAR imaging satellites. With these launches in the early 2000s, technology improvement continued and latency continued to be reduced. Now, in 2025 on the far right, we have a rendering of a Capella satellite. We are now getting into finer resolution and smaller systems due to increased technology and even faster responses, reducing the latency. As we continue to move forward, and as you hopefully picked up, latency will always be the critical factor for the consumer of commercial imagery products. One aspect of SAR is that SAR can be projected in several frequency bands. Most SAR satellites in orbit are emitting in the X band. With each frequency, there are pluses and minuses to each. As you start from X band and go to P band, your frequency and wavelength increases. So as you determine your problem set, you'll need to weigh in what works best for you. As you move across, you can see as we get into P band, the energy is able to penetrate thicker foliage and giving you that ground presence. Areas with heavy triple canopy, such as South America, Thailand, Vietnam, NASA's ALOS L band will work in any P band sensors. If you need finer resolution and don't need to penetrate foliage for, say, a natural disaster aftermath, X and C band will work. One of the biggest hindrances to utilizing SAR that we hear is that it's too complicated to understand and exploit. As with anything, constant exposure and repetitiveness of exploiting makes you feel a better explorer of SAR. But let's look at this first image. This is the Denver International Airport in Colorado. In the top right corner is a Google Earth shot. This is what the most analysts and the public can see. But let's see how it compares to SAR. In this scene, we have several features of the airport. We have terminals, we have parking lots, and then the main hub. You can also see the darkened areas highlighting the parking aprons and taxiways. But what you see here is not the correct orientation to correctly exploit this image. In an EO shot, you always want is up or north is up for best view. This is not always the case when you're talking about SAR. In the SAR image, you want to exploit in what we call shadows down. This is used to help in interpretation of an image. Now, I could spend just a week on this image talking about all the phenomenology of SAR, what you're seeing, and how to interpret it, but we have about 45 minutes, so I'll go for some key features. First is what we call layover. This is a geometric distortion from elevated features that appear to lay over onto the ground. The reason we're seeing this is that the radar beam reaches the top of the building before it reaches the bottom, and that signal returns to the sensor first. There are several factors that can influence the amount of layer you see: collection angle, height of the building, or terrain in the area. The next feature we see is a diffuse surface. This is applicable to all rough surfaces within the scene. Usually these medium gray are medium gray areas that you observe. The rough surface scatters the signal in different directions, resulting in backscatter. Conversely, specular backscatter occurs when the energy reflects off a smooth surface such as water, in this case pavement, and even sometimes compacted compressed dirt. And finally, a comparison. On the left from our friends over at Maxar is an electrical optical shot in the early morning time frame in the South China Sea. The image on the left is what you all are most likely to see if you're in the geo world and what you would see on the news. Earlier, I mentioned one of the best known capabilities of SAR is the ability to show all weather day and night. The shot on the right is on the same island on the same day, but taken at night. With the SAR image, you can see that even at night, activity is still occurring on developing this island. At the end of the day, you want to use what's best to answer the questions you and your team may have. So always keep in mind the amazing capability and function that commercial SAR can provide you. So that was just a brief rundown of what SAR is and what there's a little backstory in it. And now I'll be going into our little vendor brief on Capella itself. So first, we want to talk, we're best in class. Capella's have industry leading and imaging capability, capacity. We're fully integrated. Capella designs, builds, integrates, and operates direct taskable satellites with customer direct data delivery. We are constantly evolving. Every 12 to 24 months, we will develop and place out new satellites with continued technology. In our operational and experience constellation, we currently have 6 satellites in orbit and is planning 5 more for 2025. So this is our user interface that as a customer you would see. And I would say after all my years of experience utilizing multiple modes of collection processes, I have to say, I'm a little biased being with Capella, but I believe that our console is probably one of the most simple to use GUI interfaces out there. It's very specific. You can get down to the collection angle, you can get to ascending, left, right, everything you can think of. Conversely, if you get to that point, obviously your collection window can slow down. But if you're just looking for a specific shot of a specific area and you have some time to get that collect, you have a lot more opportunity for that chance. Big thing here is real-time status updates. So as you put your collect in and hit submit, you'll be scheduled. You'll know within 15 minutes. So right now it's 12:22 my time. So if you put a collect in by 12:30, you should know whether or not that collect has been accepted and will be passed and submitted onto our system. So we have a global network of ground stations, and as I kind of talked about earlier, step one is, what are my imaging opportunities as I want to pick a collect? You pick your collect, you get that confirmation request in 15 minutes. The uplink is scheduled, it's imaged, and then processed and delivered to you within that 3 to 6 hour time range. So as I mentioned, SAR 24/7 cloud-free imagery with unparalleled access. We have several options that you can pick from: Spotlight Ultra, Spotlight Wide, Strip Map. This all goes down to what you may need as a consumer. If you're looking at natural disaster areas, Spotlight Wide or Strip Map may be your thing. If you're trying to look for a port, as in this example, you may want a Spotlight Ultra for some finer resolution and detail. In the upper left, you can kind of see what those footprints look like in a scene. Our spotlights are 5x5, spotlight wide 20x10, and then strip maps are customizable depending on what your needs are. And if you look to your right, you can see all of our azimuth resolutions, range resolutions, and dwells available to you when you're ordering. We also have one of the largest collections of high quality, high resolution commercial SAR imagery that accesses thousands of feature-rich imagery for baseline or time series analysis. So you have that ability to go in and request an open data catalog and explore our imagery collection that we have available to the public. The bottom right is just a heat map showing you the coverage that we currently have over the area you see in the picture. We don't have full coverage over the entire world. We take pictures of substance for our customers and for potential new customers. So a little comparison, if you're a trained GeoInt imagery analyst, you'll want to factor in on the 0.25 azimuth resolution versus the 0.5. Now, if you're not a GeoInt analyst or an imagery analyst, you'll probably look at this picture and go, what's really the difference? Well, as you get down into that 0.25, obviously finer resolution brings out more detail, brings out more characteristics and more information in the image. As you can see on the left, the ship there in the middle of the image is a little bit more clear and more crisp than the one you see on the right. With us returning to SSO orbit in 2024, we now have the ability to shoot all the way up into the higher latitudes above 80 and below 80. So we pretty much have world coverage of anywhere that you need for your potential customer request. We talked earlier about what some of the applications you can use SAR for. Here's just 8 quick examples that you can use that you may need SAR for. You have some USK forest inventory. FEMA likes to do some pre-hurricane season collections to get that first look to see what the areas look like, and then we'll take that post shot after a hurricane comes through the area to produce that post coverage and kind of give some damage assessment of what has occurred. Some deforestation, flood monitoring is huge right now. A couple of conferences I've been to lately, flood monitoring, glacial melt detection is huge, and SAR is a great tool and asset to help you determine those melts and those floods. One product, we don't currently offer this at the moment, but one product that you can do from SAR is what's called a coherent change detection. So in this example here, if anybody has a water bottle on their table, all right, I want you to take a hold of that water bottle and pretend that on that first day, I just took a picture of your water bottle. I want you to drag the water bottle from one side of the table to the other. And then we're going to take a second shot of that, right? And then we're gonna measure the differences observed between image 1 and image 2, and in that you'll get that coherence map. And what you'll see is that as you drug that water bottle across from point A to point B on your desk, you see that track that has developed through there. Now, what is this good for? Obviously, you want to be in an area that is not hard packed like the runway. You want to be out in potentially open desert, area of loose soil, that you can get this change detection. So in this case, we have a vehicle that went north, came back down, and it moved around a little bit between those 2 days. But this is good to determine if a place that you're looking at is operational, if it's active, so on and so forth. Another type of product you can do is what we call two-color or amplitude change detection product. An amplitude change product is very similar to a coherent change detection product in that you're seeing the differences between two image collects. In this example here, you have a ACD and a CCD of both 6 days, and you have one of 279 days. So in most cases, as long as your collection geometry lines up correctly, you can do a two-color of 12 hours. You could do two-color of 2 months, 3 months, up to a year or more, depending if you have that right collection. I will say for consumer use that if you are wanting a two-color and you have the ability to place a CCD collect in, I would recommend putting that because the CCD geometry specifications are more stringent than a two-color. So if you order a CCD and get a CCD, you'll also get a two-color product. Capella also has a very robust analytical partner program. I think we're over like 70 plus partners right now. I think that's about the number. One of them that we work with is LiveEO. We partnered to offer 24/7 weather monitoring of 33,000 kilometers of railway across Germany. And this was used by the German government to help identify a wide range of safety hazards that could impact potential railway operations and threaten public safety. Another one that we partnered with is Jakarta. They used our SAR to analyze backscatter values and classify a wide range of surface materials and really extract shoreline extent. Again, I was just recently at 2 conferences, and coastline, shore extraction, water rising, climate change were huge factors, and SAR can kind of help fill in those gaps when there's cloud cover, right? Obviously, is the main thing on that to help really adjust those coastline features. Disaster response support. Again, this was a great example here. This is the Francis Scott Key Bridge. If you guys remember this was back in May of 2024, and the tanker hit the middle of the Francis Scott Key Bridge about 1 a.m. Thankfully, we had some members overseas that work with the company, able to put in a task. We were able to get this task collected and sent down to consumers of it, and they were able to analyze the potential initial extent of what the damage was. And this kind of help focus resources before daylight. This actually, I should have segued into that, is that this was actually taken, collected, and received before daylight. So you don't really want to send out recovery efforts, especially in a situation like this before daylight where you can't see what you're doing. So we were kind of able to give them a heads up of what was going on and where they maybe need to focus efforts at. Environmentally, this crater has experienced a rapid expansion due to climate effect. It is, however, uncovering a host of fossilized materials, allowing insight to 200 to 650,000 years of climate data. So this crater continues to grow and grow as climate change occurs and the temperatures warm up. As we all know, China is rapidly developing its navy. This is its primary, carrier and its secondary carrier that we were able to capture out at Yulin Naval Base. Again, so this was a spotlight. So this was even the spotlight Dr. Surya, 0.5 resolution, and you can clearly see the crane and key features of the two carriers. Next is what we call in the GeoInt world a poor man's two color. What I did on this image here is I took two images of similar geometry and used imaging software such as Socket GXP. QGIS can do this. I don't know if Snap can do this. I'm not very familiar with the Snap tool, but if you have Socket GXP or QGIS, you can throw these in and get a change detection product graded. As you can see here, this was about an 8-day collect. The grades difference was only about a degree. And you can see in the upper portion there, the expansion of this island in the South China Sea. Again, this is again for all kinds of other utilities, monitoring, gross change detection. The possibilities are really endless. Colorized subaperture imaging. If you've followed any of the commercial SAR providers out there, us, Umbra, ISI, you'll see that we have been posting a lot of CSI products. CSI has great utility in a number of factors, but the key factor in this is enhancing the analysis for the imagery or the GeoInt professional. In this case, we're just going to do a little theory process here and say that this was an airfield that you've been looking at for a while and you think it's dormant. You haven't seen any aircraft moving around down here, but you're going through and you're just kind of doing the cursory check, and all of a sudden you have the CSI, and you're seeing this little pattern here, and it's kind of hard to see on this inset, but you're seeing this colorized beam coming off the side, and you go, wait a minute, let me take a second look at that. So as you zoom in, you realize that during the collect, remember that SAR is illuminating. When I said you saw there said anywhere from 20 to 50 seconds, that SAR is illuminating during that entire time. It's not like an EO shot where it takes a quick picture like your phone does. The SAR is constantly illuminating over that 20 to 50 seconds. So during that time, we were able to capture probably a land air control type radar spinning. So that kind of gives you an indication that, hey, maybe this base is active and I need to take a second look at it. So in this case, CSI helped the analyst determine that this base could be active. Another great CSI, these are the ones you normally see that are out on LinkedIn and some other ones. This is the old Oakland Stadium. You can see the scoreboard down here and some of the seats. Very cool, very great shot that Mr. Klukar had taken for us. Another great aspect of CSI is, again, as I kind of showed you in that early example of the airfield, this is a piece of equipment out in Russia in the field. Again, if you're searching an open image, right, you're looking at 5 kilometers by 5 kilometers. You've got 60 more images to look at by the next 4 or 5 hours. You kind of do a quick look. CSI can help enhance your analysis by kind of keying you into key features that may not be seen in a normal SAR shot. Additionally, we can do some high resolution flood monitoring. So in this case, this is the Odar River between Germany and Poland. We ordered a spotlight wide task, basically down the whole length of the river, and covered 160 kilometers of the river that only required 10 spotlight resolution scenes, with a 1 meter resolution. One of the great things about the flood analysis, flood detection, natural disasters is you don't really need as fine of a resolution, because at 1 meter, you're going to see a lot of change occurring through a flood or a potential natural disaster. This is Mount Etna in Italy. As you guys probably are well aware, Mount Etna is constantly, the lava field is constantly exploding out there. This was a collect over, I think, about 7 days, and you can see the lava flow rapidly increasing over the 7 days. Again, this is great for scientists, weathermen, weatherwomen, meteorologists to determine how much lava is coming down, which way that may be going in towards civilian populations, disaster response, responding to start evacuations if need be. Just a great another use for SAR. I would like to say INSAR is a hot topic right now in the SAR community. Here's one that's Capella created on the Eiffel Tower. I would like to caveat this that currently Capella does not offer this product as we're still working through the process, but this is just another aspect of what SAR can provide you as you're looking at your problem set. All right, dynamic imaging. I love these. These are my favorite SAR products. So as I mentioned earlier, as that SAR is illuminating over target, it's constantly collecting. So it's illuminating with the radio waves going down, microwaves going down, hit the target, and coming back to the sensor within that 20 to 50 seconds. You're able then to process that down into sub apertures and form really a movie loop of what you're seeing in the scene. In this case, this is that CSI example I showed earlier, but here again we have that equipment that, down in Russia that likely has an antenna on it and could be rotating in the scene, causing that effect that you're seeing in this image. And this one here, this is a random rail yard in China that we captured. As you can see here, we have a train that's moving within the scene. The faster a vehicle or an object is moving in scene, the further it's displaced in the image. So in this case, you can see where the rail lines are at, and you can see the return coming off. So likely this train is moving at a very slow pace. Could even be going around that little bend right there you're seeing there at the end of that bracket. And with that, I would like to thank everyone for the time today. I hope you're able to learn some things today from not only what SAR is, but how Capella Space can assist you in your mission set. Jennifer, back to you.
Okay. Well, thanks so much, Dave. At this point, what we're going to do is open up the final optional poll. So let me do that really quickly here. And then we're going to jump straight into the Q&A period. And so we've got quite a few questions that were also posed in the chat. So I'm going to start there and then kind of rotate between the questions in the chat and then the questions in the Q&A. Okay, so let me hop up here. Just bear with me for a minute here. I gotta, and if you could enter your questions as we're, kind of progressing through this session in the Q&A panel, that would be really, really helpful, and I certainly do appreciate it. All right, so let's see here. It takes a bit of scrolling. It's kind of one of the downsides of the chat. So I'm just trying to find the first question here. And thanks for all of your patience. Okay. All right. So this is probably a question for Dana. So the question is kind of unrelated to, I believe, if the ICEYE is not found on the CSDA SmallSat Data Explorer, where can it be found?
Yeah, so the ICEYE data actually will become available through the SmallSat Data Explorer. It just has not been added yet because we're closing out that evaluation process still. So stay tuned. It should be added in within the next month or two, I would say.
Okay, thanks so much, Dana. And then some of these questions have been responded to in the Q&A. And so I'm going to cycle down here and see, let's see. I think it might be worth repeating this, even if it was answered within the chat or the Q&A. So the next question is, do you have a sense as to when the next on-ramping opportunity RFP for CSDA will be released? I believe it was in the February-March timeframe last year.
Yeah, so because that is procurement, it's a sensitive time frame, sensitive thing to share because we actually don't have an exact date set yet, but our office and our program is working, procurement office and our program are working to develop the plans and timeline for that next on-ramp, but it will be this year. I just can't give an exact date of that time frame. For existing vendors that are on our IDIQ contract, and then vendors that I have an interest in knowing when that on-ramp period will come, we strongly advise to watch sam.gov for those announcements to come out.
Okay, well, thank you very much, Dana. And I'm just going through. I do see that quite a few questions were answered here. Thanks for your patience here. Okay, so the next question is, and then I'll hop back up to the chat. Are the advanced SAR products such as CSI and CCD included in the CSDA or only the regular imagery? And I do see that Tom responded to this, but if you could just repeat the response, that would be helpful.
Let's see, that would involve me scrolling my brain back up to where the question was.
So I do see the response if this would be helpful,
Please,
and I can just,
please, thank you.
Okay, let's see. So in February, CSI will be included as a default add-on for Spotlight Ultra, 0.25 meter collects. I therefore expect it to be included as a product available to CSDA users, but let me caveat that I'm not 100% sure of that answer. And then the follow-up is CSI is included in the CSDA from Capella, but CCD is not. All the modes and products are covered in CSDA, including the CPHD product that allows you to use your own image formation and advanced processing. And so, okay, yeah, let me see here, full list of. Okay, one of the next questions is, and I don't think this has been responded to yet. Let's see, let me get back down here. Can we get a full list of products or modes that are available for CSDA and the new CESRA? So I think here it's sufficient to perhaps provide a link in the chat if that might be easier.
Yeah, Jennifer, I can comment to that. So as part of that A.48 call, our data management team did a wonderful job of putting together all of the available data from our vendors currently on contract that can help support that data call. So I'll go ahead and get the link and we can add it into the chat for folks to take a look at of that full collection of everything that we have. It's not the individual catalogs, it's just to give you an idea of the time frame and the amount of data that we have, the varying products from each vendor.
Well, thank you so much, Dana. I appreciate that. And while we're waiting on that and before the next question, I did want to, for anybody who has a question about this, we are recording this afternoon's webinar event. And what I will do, generally, it takes me just a couple of days to send out a link to both the recording as well as to Dana's introductory slide deck and the vendor presentation. So I usually send this out to not only the registrants, but also the participants. So if you have any colleagues who are unable to attend today, they will be, and they were registered, they'll be able to access the recording at a later date. This content will be posted to a new 2025 commercial satellite data acquisition playlist within our NASA Earth Data YouTube channel. I do need to create this year's playlist, so I intend to do that after this event, and so you should be looking for it there as well. And so with that, I'm going to skip on to the next question, which is, can you use this data to distinguish individual animals? If so, how? With which product exactly? Okay, so I do see, Tom, you answered. My apologies. That would depend on
No
the size
worries.
of the animal. Capella data has been used to monitor walrus migration, and it's easy to see a mass of hundreds of animals. But even with 0.25 or 0.5 meter resolution, the confidence in identifying individual animals gets lowered. Okay, so many of these, I think, let me go back up. I think all of the questions in the Q&A have been responded to. All right. I'm going to hop back up to the chat. Just to make sure I'm not missing anything. So thanks for bearing with me as I do a little bit of scrolling here. I appreciate you. Let's see here. I think we've covered everything in the chat. Just hopping around a little bit here. Okay, so making sure if I haven't missed anything here. I think that, does anybody have any additional questions here? I'm seeing a response to all of the questions that are in the Q&A. And again, if you can't see the Q&A, what you should do is click on the three dots, and you should find those dots located at the bottom of your screen. And that will pull up your panel options, where you can insert a check mark next to the Q&A panel, and that should add it to your individual, WebEx webinar interface. All right, here, I'm not seeing any additional questions, but again, let me hop back up to the chat. Oh, I do see something. Okay. Oh, thank you, Dana. So Dana has added the comprehensive list of data through CSDA to the chat. And then there is a comment. Let's see here. I can offer images whereby individual walrus carcasses are evident. However, the omission and commission errors are substantial relative to ground truth imagery from drones. I think that's a participant adding a bit of additional context to an earlier question, or additional input, I should say. All right, let me see here. I am not seeing any additional questions. So if there are no additional questions, what I would like to do here is thank all of our speakers, both from the CSDA program as well as from Capella Space, and our Q&A panelists, Jim and Tom. Thanks to Dave Jones and Dana Ostrenga, and also Aaron Kalfas, who is on from the program. And thanks to my backup host, Geraldine Tuart. And more importantly, thanks to all of you for your participation in this afternoon's event. What we'll do is we're going to leave the virtual meeting space open for an additional 10 minutes. I'll log off from the audio component, but leave the virtual meeting space open. So if you think of any additional questions, you can feel free to enter those into the Q&A, enter those into the chat. I will be providing our Capella speaker with a log of the questions, so certainly they can follow up with you offline, or if it's a question for the program, either Aaron or Dana can follow up with you offline as well. So let's just do one more quick scan. I am not seeing anything that I have missed. Give me just 1 second to make sure, though. So one of the questions earlier had to do with, I think we did respond to this. So not being able to access the data on the commercial SmallSat Data Explorer website, and the response was that the data will be added to the SmallSat Data Explorer. Somebody jump in if I don't have that right. And I do see an additional question, actually. So the next question is, what are the file types for delivery? Are they proprietary file type or standardized format like NetCDF, HDF5, or TIFF?
I'll answer that. It's your standard formats that you get, your TIFFs, anything. There's no proprietary file types at all. you can take our images and throw them into almost any type of imaging exploitation software.
Okay, well, thank you so much, Dave. And thank you. Okay, so I do have one more question that was asked in the chat. Can you use the data to detect changes in forest stress and define snow versus no snow pixels?
I'll say you can. It depends on forest stress. It always depends on the type of forest, but it's certainly worth looking at. In terms of snow versus no snow, we've done a lot of internal work on that, and the results are promising, and we'd love to follow up with you on specific areas of the world.
Okay, well, thank you very much, Tom.
I noticed Colin had a question about plans for
Yep,
future constellation upgrades.
I was just getting ready to get to that.
Oh, sorry. I don't want to take your job.
No, that's not a problem whatsoever. Yes, and so we do have an additional question. Are there plans for future constellation upgrades? And is it possible to request or task to look at certain targets? I'll toss it back over to you, Tom.
We definitely are constantly refreshing our constellation, upgrading with the letest class of satellites. And as Dave said, the plan for this year is to launch 5 more. Let's see, in terms of the AOIs, definitely that's part of our normal process. A user can drop a pin on the map and task that spot with whatever imaging mode they care for, whether it's 5x5 spotlight mode or 10 by 20, 10 by 100 kilometer strip maps.
Well, thank you very much, Tom. And we do have another question here. The question is, do your products have any topographic correction applied?
Yes, they do. We also offer products without that, and they've only been corrected to the ellipsoid, but we also have products that are geo-corrected to a local DEM.
Okay, thank you. You know, I do have a question that was received earlier. I'm going to go ahead and go through this. It's actually there are several parts to it. So this one's going to be for you, Dave. Dave, I think you mentioned FEMA and others having access to data after damages. Oh, okay, excuse me. I think if someone else is clicking on it at the same time, it makes it so that I can't see the question. So let me go back up here. Oh dear, let's see.
Yeah, I saw the question from Chris, and Chris, if you're still on, please email me. I have it down there, david.jones@capellaspace.com, and we can talk through that.
Okay. All right, perfect. And there actually are a couple of additional questions as well. So let's see here. Do we have tasking capabilities via NASA Finesse? That might be something that we need to, I don't know, Dana, if you have a response to that.
I'm just trying to find the question again.
Do we have tasking of the capabilities via NASA Finesse?
So we do have tasking capabilities through the CSDA program if there is a task order in place. If there is interest for any of the data that Capella offers through the CSDA program, whether it's in, for our federal partners or anyone funded by a US government program to access data, I would suggest reaching out to the program on the available data and any possibilities of acquiring or tasking new data through the program task orders.
Okay, thank you, Dana. And I do see that, so one of the questions, and I don't believe unless it's a little bit further down, is the interferometric SAR going to be included in the CSDA data?
Hi, this is Jim. Currently, the interferometric SAR is just internal demonstration purposes. We don't have it taskable through our console yet, and I don't think we've provided any pairs to CSDA at this time. But it's coming in the future, so future collects could potentially contain it.
And I think, thank you, Jim. And I think your response addresses the next question, which was more information about the INSAR efforts and future plans for offering suitable products. It says the example for Paris shows what looks like phase change capturing the height of the Eiffel Tower. Let's see here, making sure. Okay, so Dave, you're going to follow up with Chris. I found the question again here. Let's see. I think at this point, the correction. I think at this point, let me just double check before I say that though. Make sure there's nothing else in the chat. Oh, yes, there is one more. Are there future plans to launch dual pole capable satellites?
The rest of us on Capella's team are looking at each other, wondering who wants to be brave enough to answer that. Definitely, there are. It's part of our future roadmap. The things are being worked even as we speak. Dual pole is similar to INSAR in that these are things that we know have tremendous value as products for many purposes when doing SAR, and they have been part of our technological evolution over the course of years, and they are coming. And I'm not allowed, wouldn't even risk the guess to give you any dates, but they are coming.
Okay, well, thank you, Tom. And I do see that while we've been going through the Q&A, there are a couple more that have been added to the chat. The next question is, will we see additional polar orbiting satellites in the constellation?
Yes, that is the intent moving into 2025, 2026 is to add more polar orbit satellites. That has been a request by a lot of consumers to, as I kind of mentioned, some of that snow factor, ice melts. A lot of people are interested in that. So we have responded to that by putting some of our future satellites in that polar orbit.
Okay, well, thank you very much, Dave. And the next question is, do you produce a UDF in addition to GeoTIFF, which gives quality of the pixel?
No, we don't. But as part of our SICIDs and SIDs, we have an estimate of the R-nears, the radar nears per pixel.
Okay, thank you, Tom. Taking another look here. All right, just taking one more look. I think that I can say at this point that there are no further questions. And so once again, extending my gratitude to all of you for attending this afternoon's webinar event, or this morning's or evening, depending on where you're listening in from. And then a big thank you to all of our speakers and Q&A panelists from both the CSDA program and Capella Space. And then with that, we'll log off from the audio component and leave the virtual meeting space opened. All right, well, thanks so much, everybody. We hope to see you at an upcoming webinar. All right, take care now.